Welcome, Hornets, and thank you for joining me today. Today we're looking at this third part of our Basic Integrations worksheet. This is a worksheet that is looking at your basic derivatives as well, or basic integration formulas, as well as integration using completing the square, arc trig, as well as identities for trigonometry, and we also have U sub. So please be aware of this. This is part 3. And because of the length, I will be doing numbers 9, 10, and 11, and then stopping, and in part 4, I will do 12, 13, and 14. So please take a moment and copy it down. I would do a quick screenshot for numbers 9, 10, 11, 12, and 13. Give you that time. Alrighty, let's go ahead and begin. So we're going to start off with number 9. Number 9 has negative 2 to 2 of x squared plus 1 the quantity dx. We're going to start by distributing. So I get x to the 4th plus x squared. And I notice that I have an even function that is symmetric to the y-axis. That allows me to do my doubling area from 0 to 2. And this happens because we do have symmetry to the y-axis, and that allows me to do this. Okay? That's that even function doubling rule that we're allowed to work with. So now I'm looking at my integration: 1/5 x to the 5th plus 1/3 x cubed, and I'm going from 0 to 2. This then gives me 32/5 plus 8/3. And then I'm going to find that and double it. When I get my common denominator and add, I get 136/15. Doubled is going to give me the answer that I seek, and that's 272/15, or 18 2/15. Once again, that is using our even function doubling rule, where we can cut the function in half and double the overall area. So we're cutting in the interval from negative 2 to 2. We're going 0 to 2. So we cut the interval in half and we double the overall area. Number 10. So in number 10, we're looking at 0 to pi over 4, 1 minus sine squared theta over cosine squared theta d theta. And we do have several options that we could use if we want. For example, I could look at the integration of the 1 over cosine squared theta d theta from 0 to pi over 4. And we know that this is simply secant squared theta d theta from 0 to pi over 4. And therefore we know that this has to be our tangent of theta from 0 to pi over 4. The second piece would then give us minus sine over cosine is the tangent squared of theta d theta. And this is from 0 to pi over 4. Now most people don't realize that we can use a power reduction formula, and that tangent does have a power reduction formula. The tangent squared of theta is going to be 1 minus cosine 2 theta over 1 plus cosine 2 theta. And then that would be what I would have to integrate. Now you'll notice this is already starting to get more difficult. And what I want to just show you is that there is more than one way besides what I'm about to do. And what I plan on doing is using my identity that says that the cosine squared of theta is 1 minus sine squared theta. And if I replace either of these two pieces, for example, 0 to pi over 4 of cosine squared theta over cosine squared theta d theta, I end up simply getting d theta. Now when we integrate d theta, we get theta, and it's going to go from pi, 0 pi over 4 to 0, and my answer is pi over 4. So this is the easiest way to do it. And you'll notice I had another option, but let's be honest, this is not nearly as easy. And I'm still going to have to then deal with u substitutions and all kinds of separating of terms, looking at it in a different way, and it gets more and more complicated. So just please be aware of that. If you can find an identity that you can replace something complex with, do so. Notice here, this was a very straightforward substitution, gave me a very straightforward answer. Here, I wasn't doing a substitution, but I was writing equivalent trig ratio, or the ratio identity, sine over cosine. And it just doesn't work. It doesn't work for me. So I want to find a better way. So just be aware, BC will do this, and we'll go forward if we need to. Alrighty, that was number 10. We're now going to take a look at number 11. And let's just write down what number 11 was. That was the integration from 0 to 1/6 of 12 square root 1 minus 9x squared dx. And I can see that my a value here is 1, and I can see that my u value here is going to be 3x. But notice the du is 3 dx, and we have a 12. That means that I need to have the 4, 0 to 1/6. Then I have my 3 dx, and then I have my 1 squared minus 3x, the quantity squared. I can now see it as an arc sine. Okay. So I'm looking at 4 times my arc sine of 3x over 1, and we're going from 0 to 1/6. That's going to give me 4 times the arc sine of 1/2 minus the arc sine of 0 pi. Well, we know that sine is 1/2 at pi over 6. And we know that sine is 0 at 0 pi. So my answer turns out to be 4 pi over 6, which I reduce to 2 pi over 3. And this is the answer I'm looking for. There we have number 11. I hope that this concludes part 3, and I'll be doing 12, 13, and 14 next in part 4. I hope this has helped. If you found this to be useful, please remember to click like. If, however, you have constructive criticism that will help me to improve, please let me know so that I can become better. Thank you all, take care, and please have a very good and safe evening and a wonderful day. Cheers.